Hello, beta. Good evening, everyone. So this is the second lecture that we have on chapter 6 of Devore. And today I am going to go ahead and take a very, very important numerical in this chapter, which would be related to unbiased estimator. In the last class, I have already talked about what an unbiased estimator is. हमने property of estimator की थी. We talked about what is a point estimator. And we actually talked about why how and why point estimators are important, how we can estimate them. And we talked about two properties of point estimator, जिसमें से हमने पहला property ये बोला था that our point estimator should be unbiased. And when we said that our point estimator should be unbiased, what exactly we meant? बेटा क्या हमने बोला था? We said that when the expected value of the sample static is equal to the value of the parameter, then this can be called as an unbiased estimator of this. Theta hat will be called an unbiased estimator of theta if and only if the expected value of theta hat will be equal to the value of theta. It would be equal to the value of theta, right? This is what we had gone ahead and we had talked about. Okay, beta. Now, today I want to go ahead and I want to start with a proposition, and this is an important one. So let's say that we are going ahead and we are saying that X is binomial random variable. It follows a binomial distribution. What is a binomial distribution, beta? A binomial distribution is any distribution which can only take two values, which has a success and a failure. दो ही चीजें हो सकती है, या success होगा या failure होगा. So we are going ahead and saying that let X follow a binomial distribution with parameters n and p. क्या होता है बच्चे n? N represents the number of observation and p represents the probability of success, right? So beta, what can be said about the sample proportion? So for example, एक example के तौर पे देखते हैं. So let me go ahead and I tell you that, you know what, this is my population, right? And in this population, there are two kind of people. दो तरीके के लोग हैं. People A, who have gone ahead and watched movie, and people B, who have not watched movie. Right, beta? So people A are those people who have watched movie, and people B are those people who have not watched movie. Now I'm asking you, okay, P represents the probability of success, and I have defined my success as those people who watch movie. मेरे लिए सक्सेस वो है कि कौन से वो लोग हैं जिन्होंने मूवी देखी है, those people who have watched the movie. So what can you tell me? Population के बारे में तो हम कुछ भी नहीं बोल सकते because population is not at our disposal. Now what I have done is, out of this population, I have gone ahead and I have collected a sample. Population में बहुत सारे लोग थे. Let's say that this population, it consisted for about 1,000 people. इस population में 1,000 लोग थे बच्चे. But out of this population, I have created a sample. And this sample actually, it goes ahead and it only consists of 200 people. Now, in this sample, ये जो मेरा छोटा sample है, इसमें I can go ahead and ask each and every individual. So I go to different individual. I ask individual 1, did you watch a movie? वो बोलेगा yes या no. Then I will ask individual 2. उससे मैंने जाके same question पूछा, did you watch a movie? He can say yes or no. Individual 3, did you watch a movie? He can say yes or no. ऐसे करके I will go ahead and I will ask 200 individuals. हर एक से मैं जा जाके पूछूंगी, did you watch a movie? Did you watch a movie? Did you watch a movie? And so on and so forth. ऐसे करके मैंने एक एक से पूछा whether they watched a movie or not. right beta? And now for this sample, I know that X represents the number of people who watched movie. The number of people who watched movie. तो मुझे पता चलता है कि out of these 200 people, I noticed that it is actually 140 people who have gone ahead and watched a movie. 140 people have watched a movie, and I know that there are 200 people. So, bache, if I ask you, can you tell me what percentage of people watched the movie out of these 1,000 people? अगर मैं पूछूं कि क्या आप मुझे बता सकते हो कि इन 1,000 लोगों में ये पॉपुलेशन में कितने लोगों ने ये मूवी देखी, कितने प्रपोर्शन ने ये मूवी देखी? How many proportion of people watched the movie, but in the population में? So what can you go ahead and say? Can you tell me anything about it? You will say, look ma'am, when I collected data of this sample, जब मैंने ये 200 लोगों का data collect किया, I realized that out of 200 people, 140 people have watched the movie. तो मेरा जो p hat आया, which is x by n, this came out as 0.70. So I am very sure that ma'am, in my sample, जो मैंने 200 लोगों का sample collect किया, in my sample 70% of the people have watched movie. In my sample, मेरे sample के अंदर 70% लोगों ने, 70% of the people have watched the movie. Now but I go back and I ask, अच्छा क्या मेरे को इससे आप population के बारे में कुछ बता सकते हो? इन 1,000 लोगों के बारे में कुछ बता सकते हो? तो maximum what you will be able to tell? You will say, ma'am, according to me, it is my estimate that this movie in the population also has been watched by 70% of the people. मेरे को ऐसा लगता है कि सैंपल से जो मैं अपना इंफॉर्मेशन कलेक्ट करके लेके आई हूं या लेके आया हूं, whatever information I have collected, it seems to me that because in sample 70% of the people have watched the movie, it should be the case that in the population also 70% of the people have watched the movie. तो मुझे ऐसा लगता है that in the population the proportion of people who have watched the movie is 70. Clear? बेटा, this is what this is saying. ये बोल रहा है x is binomial random variable. X is binomial random variable with the parameter n and p. So there are two parameters to it. N is the number and p is the proportion. The sample proportion p hat is given by x by n. Sample में हम proportion कैसे निकालते हैं? x by n करके. And now we are saying that it is unbiased estimator of the population parameter. मतलब जो मैंने अपने सैंपल के बारे में ये इंफॉर्मेशन निकाली थी, the information that I had found out about the sample, अगर मैं इसकी expected value निकालूं, it should be equal to the value of the population. माने इसका क्या मतलब है? Let us try to understand the thing a bit more. इसी proposition पे थोड़ा और काम करते हैं हम. So take an example बेटा. Suppose मैंने आपको बोला फिर से, I have these 1,000 people. या तो उन्होंने मूवी देखी है या तो उन्होंने मूवी नहीं देखी. Either they have watched the movie or they have not watched the movie. अब मैंने क्या किया ना, मैंने इससे sample 1 निकाला. Sample 1 consists of 50 people. 50 लोगों का sample निकाला. And I asked how many people have watched and not watched the movie. तो आप मुझे बताते हो that ma'am, out of these 50 people, I see that 30 people have watched the movie and 20 people have not watched the movie. मैं कहती हूँ okay fine. फिर मैं अपने दूसरे स्टूडेंट के पास गई. I go to the second student and from that second student बेटा I ask that second student to collect a sample. वो second student भी एक 50 people sample collect करता है. He also collects a 50 people sample. And I ask the second student, बेटा can you survey and ask people whether they have watched this movie or not? एक बार जरा पता करके बताओ. So he in his sample finds out that out of this 50 people, 30 people have watched the movie and 20 people have not watched the movie. He also gets the same result. Now beta, I asked student number 3 कि बेटा क्या आप भी अपना एक sample निकाल सकते हो? So he also collects a sample of 50. And I ask him, Acha, how many people watched the movie? He tells me, ma'am, in my sample, 35 people have watched the movie and 15 people have not watched the movie. ऐसे कर करके I can ask many people to find this sample. So maybe I have asked 20 students to find different samples. 20 लोगों को मैंने बोला कि ये छोटा छोटा sample निकाल. Or maybe I've asked 10 students to find the sample. And for each sample, I will get some probability of success. Success is watching the movie. So यहाँ से you get success as 30 by 50. From here, also you get 30 by 50. From here, you get 35 by 50. And so on and so forth. Clearly, we know that this is going to be a random variable. ये अपने आप में एक random variable है. That is also known to us. Now what I go ahead and I do is I create a probability distribution. तो मैं बोलती हूँ कि okay, 35 by 50, this value has been seen only once. सिर्फ एक बच्चे को probability of success 35 by 50 मिला. 30 by 50 has been seen 4 times. 40 by 50 has been seen 2 times. ऐसे करके मैंने एक probability distribution बनाया, right? So this is my P hat कि क्या proportion मुझे success का दिखा. What is the proportion of success that I have seen? And this is their probability that 1 out of 10 times I saw, 4 out of 10 times, 2 out of 10 times, and so on and so forth. So I have a variable in hand and the corresponding probability in hand. I will be able to find expected value of that variable, which is summation P hat into its probability from I1 to N, jitne bhi honge. You will multiply this with its probability, this with its probability, this with its probability, and add. जब ऐसा करोगे, you will get the expected value of P hat. Clear? Now, मैं क्या बोल रही हूँ? What is my claim? That this expected value that you will get, इस P hat का जो expected value आएगा, this expected value that you will be getting, this will be equal to the value of the population. ये population के पैरामीटर के बराबर होगा. This is called as being unbiased. इसको बोला जाता है that this parameter is unbiased. Am I clear with this? So we are saying, so what is our proposition? Let's go back. Our proposition is that X is binomial random variable. Its parameter is N and P. And we are going ahead and saying that I have created a sample proportion. मैंने एक sample proportion निकाला है P hat. If I go ahead and I find the expected value of this sample proportion, I will find that it will be unbiased estimator of P. मुझे दिखेगा कि ये P का एक unbiased estimator है. This is what it is the meaning of this proposition, right? Okay, beta, let's take an example now. So this is example number 6.4 of Devore, in case you want to refer back to the book also. So reference is 6.4 Devore. This is an excellent example, very important example. Very good, very, very good example. Let us try to read this out better. So it says that assume that X is uniformly distributed between 0 to theta. Right? And so just try to see this thing. If I just go ahead, I'm going to use some of your information from the earlier chapters of Devore. पहले पुराने जो chapters हमने पढ़े हैं Devore के, उससे थोड़ी हम ये information use करेंगे. So X is uniformly distributed between 0 to theta. हमने यहाँ पे 0 ले लिया और यहाँ पे theta. What will be its PDF, बच्चे? So we know that anything which is uniformly distributed, its PDF can be given by 1 upon B minus A. B is the upper value, theta, A is 0. So this is going to be 1 by theta. So I will go ahead and I will get that its PDF will be 1 by theta. So which means that this is going to be 1 by theta. And I can go ahead and I can create something like this. Clear है बात? Okay, we know that this is also CDF. अगर मैं ये area निकाल दूं, this rectangular area, that will give me CDF, right? And the total CDF has to be 1. That's also something we are aware of. ठीक है बेटा, अब आगे बढ़ते हैं. So now what goes ahead and happens is, it says because x is uniformly distributed between 0 to theta. That means that the maximum value that x can take is theta. Theta से ऊपर तो नहीं जा सकता ना. The maximum value x will be able to take will be theta because it is uniformly distributed between 0 to theta. Clear? Now what we go ahead and we do is, so we want to go ahead and we want to collect a sample. अब ध्यान से मेरी बात सुनना. Imagine that this is a population. ये population में बहुत सारा values है, but I know that all those values have to lie between 0 to theta. थीटा को एक्सीड नहीं कर सकते, दैट्स द अपर लिमिट, एंड जीरो को जीरो से नीचे भी नहीं जा सकते, दैट्स द लोअर लिमिट. आई गो ahead and I collect a sample from this population. Right? Sample में I have some observation. Say x1, x2, x3, x4, x5. ऐसे करके sample में I have some observations. Clearly, because population में ही maximum value theta थी, the value could not have exceeded theta. Theta से ऊपर value तो नहीं थी ना. So because in the population, the maximum value was theta, we are clear that in the sample, जो भी मैंने sample का observation लिया होगा, none of them will exceed theta. उनमें से कोई भी value ऐसी नहीं होगी जो theta को exceed कर जाए, theta से ज्यादा हो, because the sample is taken from the population and population's maximum value is theta. So each observation of the sample will be up to theta only. So this helps us understand that x1 will be less than equal to theta, x2 will be less than equal to theta, x3 will be less than equal to theta, x4 will be less than equal to theta, x5 will be less than equal to theta. None of them can exceed theta. इनमें से कोई भी theta को exceed नहीं करेगा. Now based on the sample, I will create some estimator. मैंने कोई एक estimator बनाया. बच्चे that estimator can be anything, mean, median, mode, range, domain, etc. कुछ भी लो वो estimator. But क्या वो इन वैल्यू को exceed कर सकता है जो वैल्यू सैंपल के अंदर है? No, because वो जो है वो इन 5 वैल्यू से ही created है. So whatever estimator I would have created, जो भी मैंने estimator बनाया होगा सैंपल का, वो इसको exceed नहीं कर सकता. It cannot exceed the excess that have been created here, which cannot exceed theta. तो मैं ये बोल सकती हूँ कि मेरा जो भी यहाँ पे सैंपल एस्टिमेटर होगा, जो भी मैं एस्टिमेटर निकाल रही हूँ, सैंपल का एक स्टैटिक वैल्यू निकाल रही हूँ टू एस्टिमेट द पॉपुलेशन थीटा, कि ये थीटा कितना होना चाहिए, टू एस्टिमेट द पॉपुलेशन थीटा, आई एम प्रिटी श्योर that it cannot go ahead and it cannot exceed the maximum values that have been taken here. समझे बात को? Let me explain you through one more thing. Example. Suppose I tell you मेरे पास एक population है. And I tell you कि इस population में से बेटा I have gone ahead and I have find it 4 values, जिसका मैंने एक sample बनाया. And I tell you that these 4 values that I have taken are 10, 12, 14, 10. ये 4 values मुझे मिली, sample इन 4 values का है. Can you tell me what will be the mean? Mean will be 10 plus 12 plus 14 plus 10 divided by 4. So this is going to be 14 plus 10, 24, 34, 46 divided by 4. So this is going to be 11.5. It will be 11.5, right? Can you see clearly that suppose I tell you कि मेरे को population का mean estimate करना था and मैंने वो sample के mean से estimate किया using the property that sample mean is an unbiased estimator of population. Can you see कि जो मैंने यहाँ पे estimator निकाला है this is less than the maximum value that exists here. वो 14 को नहीं exceed कर जाएगा. 14 तो upper limit है ना. It won't be able to exceed 14. Same is the case here. ये सारे के सारे एक्सेस थीटा से कम है. तो जो हमारा थीटा हैट है वो मैक्सिमम किस वैल्यू तक जा पाएगा बच्चे? It will be able to go maximum up to the highest value. जो इनमें से पांचों में से जो भी highest value रही होगी, whatever would have been the highest value among these 5 values, उससे ज्यादा वो नहीं जा पाएगा. Whatever that theta hat may be, जिस भी तरीके से मैं वो theta hat निकालूं, whatever method I use to find that theta hat, it cannot exceed the 5 x's that I have. And these 5 x's in further, they cannot exceed theta, right? So I am going ahead and I am saying that let my estimator be the maximum value of the x's. Try to understand this thing. ध्यान से समझने की कोशिश करो. मेरे सारे एक्सेस 0 से थीटा के बीच में है. एक और एग्जांपल लेते हैं टू मेक दिस थिंग अंडरस्टैंड. सपोज मैं आपको एक वैल्यू बता दूं. सपोज मैंने आपको बोला दैट दिस इज माय पॉपुलेशन. माय पॉपुलेशन इज यूनिफॉर्मली डिस्ट्रीब्यूटेड बिटवीन 0 to 10. बेटा क्या हो सकता है? ऐसा कुछ हो सकता है दैट यू क्रिएट सैंपल 1 जिसमें से आई टेक 4 ऑब्जर्वेशंस और वो ऑब्जर्वेशन आती हैं 5, 7, 9 और 10. और दूसरा केस हो सकता है दैट आई टेक सैंपल 1 एंड आई टेक 4 ऑब्जर्वेशन एंड दे कम आउट टू बी 4, 5, 7 एंड 9.5. तो या तो ये होगा either this will happen कि जितनी भी यहाँ पे ऑब्जर्वेशंस आई हैं, whatever observations you see here, all of them will be less than 10. Or maximum they can go till 10. Can they exceed 10? No, क्योंकि this is uniformly distributed between 0 to 10. So if this is uniformly distributed between 0 to 10, we are pretty sure that whatever observations we have found out, they will never exceed 10, right? So when I will be going ahead and I will be finding my theta hat based on the maximum values that I see here, either I will be able to get 10, which is exactly the value of theta here, or what will happen? Or when I try to find out theta hat, which will be maximum of 4, 5, 7 and 9.5, I will get 9.5, which will be less than the actual value of theta, which is 10 here. But the maximum I can do is find the maximum value of the sample. Okay, so this is what I have done here. I am finding the maximum value of the sample. Now, my claim is that if I use this to estimate theta, अगर मैं इस formula से theta hat के theta को estimate करती हूँ, if I go ahead and I use this technique to estimate theta, then my claim is that it would be an unbiased. It would be a biased estimator, right? My claim is that if I go ahead and I find the expected value of theta hat, it will not be equal to theta. वो theta के बराबर नहीं होगा. It will not be equal to theta. This is what this example is about, right? And this is very easy to prove through this only. इस example में हमें दिख गया ना. So if I take the maximum value of this sample is coming out to be 9.5. Suppose मैंने से 3-4 samples लिए, right? So suppose I go ahead and I tell you कि this is my population. This is uniformly distributed between 0 and 10. I take sample 1. उसमें observation आती है 4, 5, 6, 7. I take sample 2. उसमें observation आता है 9.5, 8.7, 4, 1. I take sample 3. उसमें observation आता है 9.99, 8.71, 7.65 and 4.84. ऐसे करके मैंने बहुत सारा samples लिया, right? यहाँ पे maximum value comes out as 7, maximum value comes out as 9.5, maximum value comes out as 9.99. I take some more samples. वहाँ पे maximum value comes at 8, comes as 8.5. So you see कि किसी भी sample में it is possible ना that none of the sample has maximum value 10. ऐसा possible हो सकता है. So even if I will take the expected value of these sample in हर एक साथ add करके even if I find their mean, so it will be less than 10 ना. It will be less than theta, right? क्योंकि theta was 10. Even if I find their expected value, so it will be less than theta. बेशक ये 9.9999 क्यों ना आ जाए, it will be less than theta. So it is possible ना that this will be a biased estimator. Isn't it? It is giving me a biased estimator ना. It will be unbiased only when I find these 5 samples और हर एक में I find that the maximum value is 10. मतलब हर एक में by luck 10 include हो ही गया sample के अंदर. तब अगर मैं सारे 10 का मीन निकालूंगी I will get expected value of 10 as 10 और तब वो थीटा के बराबर होगा. But that will not always happen, right? वो हमेशा थोड़ी हो सकता है. So therefore we are claiming that theta hat, which is found as using this formula, that we are going ahead and finding the maximum value of the x's, this is going to be a biased estimator of theta. It will be a biased estimator of theta. अब देखो, we are clear that it will never overestimate theta. क्यों? क्योंकि हम overestimate क्यों नहीं कर सकते? क्योंकि overestimate करने के लिए हमें जो वैल्यू चाहिए होगी वो थीटा से ज्यादा चाहिए होगी. बट व्हाट आर वी डूइंग? वी आर फाइंडिंग थीटा वन हैट यूजिंग द मैक्सिमम वैल्यू ऑफ द एक्सेस. हम जब एक्सेस का मैक्सिमम निकालते हैं तब हमें थीटा वन हैट मिलता है. और ये एक्सेस कहां से आए हैं? These excess have come from such a population. ये एक ऐसी population से आए हैं जहां पे maximum value ही थीटा है. तो ये एक्सेस थीटा से ज्यादा नहीं हो सकते. तो अगर हम इन एक्सेस का मैक्सिमम भी निकालेंगे, दैट विल ऑल्सो नॉट बी मोर देन थीटा. तो वी नो कि हम कभी भी थीटा को ओवर एस्टिमेट नहीं करेंगे. हम जब भी इनका मैक्सिमम निकालेंगे, थीटा हैट निकालेंगे, इट विल नेवर बी मोर देन थीटा. But it can be less than theta, like the example I showed you. It can underestimate theta, right? So this is exactly what this example is talking about, that you may not be able to overestimate theta, but you can definitely go ahead and underestimate theta. Am I clear with this? Okay, beta. So I will stop this session for today right here, right? There is this formal proof that I will be doing in the next class, and then we will be talking about the principle of unbiased estimator and minimum variance. Okay, beta. Thank you.